Today we're going to talk about applications of sequences and series, and basically the gist of it is you're going to write down the sequence based on the problem and then use your formulas, either finding a term or the sum, to answer the question. And so in this first one, in skydiving, she falls 16 feet, so we're going to put the negative in front for directional for falling, then 48, then negative 80, and that pattern continues. And as we analyze that further, that is an arithmetic sequence, and the common difference each time is negative 32. So the question then says, how many feet will she fall during the 10th second? So that means we want the 10th term. So we're going to go back to the formula. I always start with the formula so that I'm not just pulling numbers randomly and you can see where they come from. So they want the 10th term. So the first term was negative 16. I'm going to plug in 10 minus 1, and the common difference was negative 32. And then we're just going to throw that into the calculator, and a sub 10 is negative 304. So the negative, which is directional, which means that she's falling, so she falls 304 feet during the 10th second. And so in this particular case, we're looking for the 10th term in the sequence. So we use our formula and we answer the question. Okay, now we're talking about a pile of bricks. There are 85 in the bottom row, 81 in the second row, 77 in the third row, and it continues until there's 1 in the top row. This is also arithmetic. This time our common difference is negative 4. That's what we're adding term to term. Each row has 4 less bricks than the one ahead of it. And this time they want to know how many bricks there are, so that's the sum. But first I need to know how many rows there are. So first of all, let's set that up. So I want to know the sum. So I need n over 2, first term plus last term. Okay, well the first term is 85, the last term is 1. I need to know how many rows there are. So now I go back to this formula and plug in what I know. So the last term is a 1, the first term is an 85. I'm looking for how many there are, and the common difference is negative 4. So plug and chug. Now we're going to solve the algebra equation. So this gives me negative 84, and this gives me negative 4n plus 4. And when I subtract, I get negative 88 equals negative 4n. And so n is 22. So that means there's 22 rows in this brick pattern here. So now I want the sum of, actually we can be more specific. Now I want the sum of the 22nd row. So 22 over 2. My first term was 85. My last term was 1. And then we throw that in the calculator and we get 946. And that 946 is the total, is how many bricks in all. And you really, I don't need anything specific as far as how to answer that, just manipulation of the formula and finding the answer. Okay, next one. It says 64, in the first row, 62, 60, that pattern continues, and there's 24 rows altogether. So this is also arithmetic, and now we see that the common difference is going to be -2. And the first thing I want to know is how many seats are in the last row. It says there's 24 rows altogether. So we're going to start with this, a sub 1 plus n minus 1d. And in the 24th row, n is 24, 64 plus 24 minus 1 times our common difference, -2. And then that's going to go right into the calculator. A sub 24, that's 18. And so that 18, this is the number of seats in the last row. Okay, number of seats in the last row. Now, they wanted to know how many seats are in the theater. So that implies the sum of this sequence, n over 2, a sub 1 plus a sub n. And so now I want to know the sum of those 24 rows. So 24 over 2, the first term is 64, the last term is 18, and then that goes into your calculator, and the sum of 24, that would be 984, and the significance of 984, that is the seats in the theater. So that's the total number of seats. Okay, one more, and in this one's got a little bit different twist. It starts with a sequence, 61, 58, 55, and that pattern continues. It tells us, and this is also arithmetic, and it also tells us what we want, how many layers are there. So we're looking for n. They told us that the sum of the layers, though, there's 639 logs in all. Now the problem with this one is we don't know the last term. So we have to use an alternate formula, S sub n, and we're going to use 2 times a sub, whoops, sorry. If I knew the right formula, we'd be even better. Okay, here we go. N over 2 times 2 times a sub 1 plus n minus 1d. Okay, now let's plug in what we know. 639 goes over here. N over 2, 2 times 61 plus n minus 1 times the common difference. We're going down by 3, -3. Okay, now we have to solve for n. So first thing first, clear the fraction, double over here, 1278, n times 122 minus 3n plus 3 in there, and that gives us 1278, and let's see, 125n minus 3n squared. So this is now a quadratic, so we're going to swing the 3n squared over here, minus 125n plus 1278, and we're going to set that side equal to 0. And then what happens next is we do the factors, so a 3n and an n and an 18 and a 71, minus and minus. And so our first parenthesis says, let's see if I can move my box here, that n is 71 over 3. We cross that off because it has to be an integer, or we say that n is 18 And so, finally, to answer the question, there are 18 layers. Now, all of the examples here dealt with arithmetic. There are a couple basic examples for geometric, and you're just going to work those formulas to find the desired number of terms or which term they want when you see the assignment.